Welcome to the final demonstration and presentation for Team 10. Team 10 consists of Sean Fonte, Amin Ghafour, myself, Robert Graves. Today we're going to talk about the project objectives, and then we're going to discuss the design for each of our instruments. We're going to go through important and unique design features, briefly discuss the physics, discuss how a design changed from original proposal, cover final costs, lessons learned, and then any improvements that we have moving forward. You might recall our project objectives were to build three musical instruments capable of playing either Ode to Joy, ASU's alma mater, or ASU's fight song. It needs to include a wind, string, and percussion instrument. All instruments must fit into a 2x2 by 2 foot stage box. Cost can't exceed $15. Instruments need to be aesthetically pleasing, and no more than 10 feet of pipe may be used, and no more than 6 feet of string can be used. Next up, I'm going to talk about the panpipe instrument that we came up with for the high voice wind instrument design. For the high voice wind instrument, band came up with a set of panpipes that sound something like this. So overall, there's 13 pipes in this set that are specifically tuned to play the high and the mid-high voice ranges for ASU's alma mater. Pipes are easily going to fit into the 2x2 by 2 foot stage box, coming in at 14.5 inches long by 1 2/5 inches tall by 19 1/5 inches wide. Cost was $12.17, and it's finished in a nice maroon and gold color to match the band's name. On the physics, we've got still a single open-ended design with end effect corrections calculated. The design changes that we had, we used 3/4 inch PVC pipe instead of 1 1/4 inch, and then used a single wooden frame instead of a double frame. Found out that pipes would be exceeding the 10-foot pipe limit if we used the 1/2 inch PVC, so we need to go longer, and then found out that the single wooden frame was strong enough to secure the pipes. Again, the final cost came in $12.17, which is well under budget. Some of the lessons learned here is found out that not all PVC pipes have the same inner diameter, and so each pipe required a little bit of fine-tuning as we got closer. Just highlighted the importance of prototyping and testing models in real life to make sure that they're going to work, and then just test early and often. So some design improvements, might look at a curved design in the future, make the pipes a little bit lighter. They seem to be a little bit heavy. And if the band needs any additional notes for other songs, just more pipes would need to be added.
Thank you, Robert. As you can see, the thumb piano features 9 tines, tuned specifically for the alma mater low voice range. Each tine was adjusted in length to play one of 9 tones between G2 and B3. Dimensions for the thumb piano are 8 inches long, 5 inches wide, and 2 inches high, so it'll easily fit within the 2 foot cube stage box that we're limited to. Total cost was $6.36, and the wood surface was treated to a coating of shellac to enhance the wood grain, so I'll just add a nice finishing touch. For the physics, so cantilever beam calculation was used for the thumb piano. We used the equation for the modal frequency of a cantilever beam, which is given by frequency is equal to m squared times pi times kv divided by 8l squared. So the length is equal to the square root of m squared pi kv divided by 8 times the frequency. So design changes. The original design was a xylophone, but we faced challenges trying to tune each bar, so the decision was made by the group to change the instrument to a thumb piano, which was we were able to meet the requirement for the frequencies. While building the thumb piano, one change was made whereby we replaced a hacksaw blade with a thicker metal bar for the flat bridge to maintain a more uniform clamping force across all the tones. So as you can see here, this is a breakdown of the parts used to build it, and again, grand total of $6.36. So lessons learned, well, we need to start testing at a very early stage in the design process to prove the concept will work. And also, too, we need to ensure that we have alternatives. So design improvements needed to this, tines need to be buffed to remove any sharp edges. And again, shellac was added to the wooden block to enhance the wooden grain. On to you, Sean.
Thank you, Amin. For the medium voice stringed instrument, the group produced a cigar box guitar. It features 3 strings and 12 frets that cover all the necessary frequencies while remaining inside the budgetary constraints, with a final cost of $13.35 and size constraints with an overall dimension of 20.6 inches, 7.2 inches by 2.7 inches. The guitar has been given a mahogany stain and sounds like this. The string lengths and theoretical frequencies were determined using the formulas for tension and frequency displayed on the screen right now, with the produced frequencies being an average of less than 1% different from final calculations. At the beginning of the design process and initial build, the nut at the top of the fretboard is made from the same wood as the neck. This made tuning very difficult. As the tension from the strings pressed them into the nut, the string length and tension would change, altering produced frequencies. The nut was replaced with a piece of hard plastic with notches to maintain proper distance between strings. The guitar was built with narrower mandolin frets, which I decided upon because I wanted extra space between the frets to maintain playability. I did not consider that these frets were also much shorter and designed for different strings. While the guitar is still very playable, it takes more effort to fret than it should. I believe using standard guitar fret wire would have been a better option. Throughout this presentation, Team 10 has shown quantitatively that all 3 of our instruments meet and exceed the standards set forth at the beginning of the project, and do so at a high level. Thank you for your time.